Good afternoon, everyone. I'm Tim Richards, Technical Services Manager of the Managing General Agents Association, and on behalf of the MGAA, I'd like to welcome you to our briefing this afternoon. This is being delivered by Encora on the subject of Gen IA, your underwriting and distribution Copilot. Before I introduce our presenters, I'd just like to run through a few housekeeping points. Please ensure your microphone and camera are turned off. If you'd like to ask a question, feel free to use the chat facility at the bottom of your screen. Time allowing, these questions will be asked and answered at the end of the event. If we run out of time, questions will be answered after the event. This session does include a poll, just to reassure you that this is anonymous. This presentation is accredited for CPD hours if relevant to your ongoing professional development program. This briefing is being recorded, and a link to the recording will be issued post-event together with the slides and our feedback survey. Please take the time to complete our survey. It takes no longer than a couple of minutes and really helps us to deliver the best possible future events to our members. So as a recap, today's briefing is on the subject of Gen AI, your underwriting and distribution Copilot from Encora. So let me introduce you to our presenters, Daniel Ginger and Mark Hollyoake. Daniel has had 15 plus years of expertise in financial services, especially in insurance, risk management and payments. As VP, Consulting and Business Solutions, Insurance and Banking at Encora Europe, he specializes in driving impactful business transformations through the strategic integration of technology and changing the organizational culture towards a data-driven one that embraces the opportunity of redefining their businesses. Mark is a seasoned strategist and innovator, currently spearheading the development of cutting-edge Gen IA concepts in the insurance industry at Encora Inc. Previously, with multinationals like Capita and HPE, he has successfully led strategy, innovation, and excellence in AI, data, and low-code practices. He is pursuing a PhD in deep reinforcement learning and holds an MBA MSc in systems design and a BSc in computer science. Mark is dedicated to pushing the boundaries of technology and creating transformative solutions for clients navigating their generative AI landscape. So without further ado, enjoy the briefing, everyone, and I'll pass you across to Daniel.
Thank you very much, Tim. Good afternoon, everyone. Before getting into today's topic, I will go back to the first slide of my presentation of my and Mark's presentation, just for a disclaimer. So this is indeed a mix of human-generated content and generative AI content based on the prompts that were issued basically by me and Mark. And actually, the webinar is performed only by humans, luckily enough, although we shall see what will happen across the years. I guess this type of disclaimers were even asked in some social media contexts, because I guess it would be really interesting for us as content consumers basically to understand who generated what and in which way, just to understand what's behind that. Thank you, Tim. So now going to our agenda, today's session will be basically a duo between me and Mark. And the three main topics that we will touch basically are around describing the role of generative AI for insurance and how we could leverage it, outline how Gen AI can be used as a supportive tool for underwriters and claims handlers, and not only, and identify the risk associated with Gen AI implementation in general. So in the agenda, basically, we have the following sections, and we will start basically with a short introductory session to generative AI. But before that, we will launch a short question, a short quiz. So I will ask you to answer to the following question. Have you been using ChatGPT or any other Gen AI tool for work-related tasks? Yes, very often. B, sometimes. C, not yet. But I will like to do that. And D, never. As I was mentioning in our earlier disclaimer, we have used ChatGPT, the free version, just to generate some things in this presentation. But it seems that we don't do that necessarily very often, although this might change in the future. So the results are coming. Thank you for answering to this. I will give a short recap just for the ones that will see the recording and are not able to see the poll. So it seems that 16% of the respondents are using GenAI tools very often, 32% sometimes, 32% not yet, but it seems they are interested, and 20%, 1 in 5 persons have not used until now a GenAI tool. So I would say around half of the people have used already GenAI tools, and another 32% it's willing basically in the future to use this sort of tools. Thank you very much. This enables us to understand better our audience and in the same time reflect on how it is used currently, the various tools on GenAI. Now, going back to our agenda, introduction to generative AI. What it is generative AI, because we do hear about AI for years already. How is generative AI different than the AI from years ago? So basically, generative AI is a subset of artificial intelligence that creates, as the name suggests, generates new content such as text, images, or audio that resembles human-made content based on learned patterns from training data. And we will touch on several topics in the following slides, like the training data, patterns, and how this content is actually generated. But before that, I would like to go beyond buzzwords that involuntarily we will all hear in the articles that we'll read or inside our organizations. And I hope through this short AI lexicon will enable you actually to navigate easier in the discussions that you have in your organization or in any other context regarding GenAI. So I've just selected 4 main, let's say, terms that are usually used, and the latest, late last year, I would say some of the terms were so new that actually in a context, I was just trying to figure out what are these people are talking about. So we will start with the LLM, or which comes basically from large language model. And probably maybe it doesn't sound necessarily familiar like an LLM, like a term for you, but because people are using more like examples and applications of large language models, like we are talking about GPT version 3 or 4, or the ChatGPT in general. So basically, large language models are an advanced type of AI model trained on vast amounts on text data to understand and generate human language. Now, the second term is about prompt, and maybe you will hear more and more often in a combination like, we are looking after prompt engineers. So what does a prompt means and what a prompt engineer should do? Basically, is the input that a human is giving to the AI model, to the generative AI model, in order to produce a response or some content. Prompt or prompt engineers. Now, the following term, which I guess it's really important, and you will see why, because this will enable us to help some problems that we have heard in connection with generative AI, like hallucinations. Retrieval augmented generation, or RAG. Think of it like a super smart assistant that not only answers your questions, but also does a quick search to make sure the answers are accurate and detailed. Sometimes it actually enriches the answers that it's providing towards you. And last but not least, this term, I would say it's for several years with us, but in this context, it's also very important, like neural networks. Basically, neural networks are computational models inspired by the human brain, consisting of layers or nodes that process data and learn patterns. We could say that it's more like a kit that it's learning from data to process data and learn patterns. As examples, we have for image generation, generative adversarial networks or variational autoencoders. And you will see later why these are a bit different than the large language models. Now, going forward, how we could use GenAI? Yeah, so we have a new tool basically, but how does it enable us to do better and what we can do better with GenAI? So definitely it will help us in data handling and how we ingest various data. It will help us in personalization and risk assessments, in our underwriting journeys, in our customer interaction, in the product development, last but not least, actually in increasing efficiency. How does Gen AI work? Actually, Mark will tell you more about that. But before that, yeah, actually, I guess we could go directly to Mark and just to help us in a nutshell in describing how Gen AI work. And don't get scared about this diagram. Mark will take the floor, and it will make it very easy for you.
Yeah, and happy afternoon. Yeah, so looking at Gen AI as opposed to traditional, or what we call discriminative AI, we've been using the things on the left for trading, online trading, for dynamic pricing, in actuarial sense, ad spend, Google ads, and also demand forecasting. But we're rapidly moving into the area on the right where we generate. Generative is all about how do we create, as Daniel said, new content, synthesized content to help us with our work. So, for instance, creating meeting notes based on and summarizing documents, and customer-facing chatbots is. Well, that's generally how people get sort of introduced into the world of Gen AI through ChatGPT type interfaces. Yeah, so you're actually, when you're talking to a chatbot, essentially ChatGPT is a chatbot, but it's a large language model, as Daniel referred to, sitting behind it, which with all the intelligence behind it. So what's the main differences between the two? We've got the approach of the traditional side, the discriminative AI, which uses something called supervised or unsupervised learning. Supervised when you're basically saying, I've got a picture of a cat, I'm labeling it as a cat and training the AI to recognize a new type of cat in the future, many times training, and eventually you'll get it right and making predictions on that. And unsupervised learning, where you say, I've got a whole load of data, where is it clustered around? Where are the clusters of data which are tightly correlated? Well, in generative AI, the approach is different. It's about creating new data, but it's and certainly with large language, and the key is the word large. The large language model is extremely complicated because it's having to be trained on all the internet, essentially, all the content available on the internet. It needs to know that to recognize patterns to be able to generate something effectively at the output side. So the purpose of Gen AI is mainly used for creative tasks, text generation, image synthesis, and you may have come across video generation, for instance. Now they're going into music composition, but mainly on the creative side. As opposed to the traditional side, which is all very task specific. You're classifying images, for instance, we talked about cats, or predicting values like dollar values of something, right? That's prediction, as opposed to generation. The data requirements are completely different between the two. As we mentioned, on the left-hand side traditionally requires labeling. So there was Amazon, we all know Amazon, they asked a whole load of volunteers a few years ago to manually label images. Mechanical Turk, it was called. Well, there are much more sophisticated ways of labeling nowadays, but on the Gen AI side, you don't need to label anything, but it looks for patterns across a huge amount of text. In the end of the day, as Daniel said, everything has to be used in an LLM, which is sitting behind the ChatGPT, the large language model. Its language is the next word. It needs to understand text, and it understands a huge array of languages based on what it can see in text. And it's based on the Gen AI stuff. There are various models, a couple of which Daniel mentioned, but the one that's behind ChatGPT is what's called transformer. And what it does essentially, if you remember on the mobile phone, you're doing predictive text, so you type in some text in, and it predicts the next word. it's a bit like that, far more sophisticated than that, but actually it's trying to use whatever you're typing in. Daniel mentioned the word prompt, right? That's what you're typing into it. But it needs to be able to see something in there and then look for a pattern that matches what you're asking for, and then predict what that might be. And it could be an image, it could be video, it could be simply speech or text. Yeah. So the limitations. So with the discriminative side, the traditional side, it requires an explicit rules and predefined features, whereas on the generative side, it's capable of learning complex patterns and generating novel content. And it's far more flexible and it's more adaptable and can generate diverse outputs based on input variations. Whereas on the left-hand side, the traditional is actually less, it's more rules-based. So training time, huge difference between the two. One, in order to train on the left-hand side, it's a lot less than on the right. On the right-hand side, it just came across statistic. Every time OpenAI, who's created ChatGPT, every time they bring out a new version of model, it consumes electricity of an island. And that just shows you the amount of power and therefore driving data center problems about energy and all the rest of it just to do a training run. And it obviously takes a long time to do it.
Given the electricity consumption, maybe we should start measuring the carbon footprint of generative AI models. So thank you very much for the explanations on the complexities on that. Of course, most of us will be interested. So we do understand that there is a lot of complexity around generative AI, but how we could use generative AI in our day-to-day businesses, and not want to scare anybody, but in the enterprise great solutions, basically, what we are doing and what companies, general in the insurers, brokers, MGAs are trying to do in order to bring this to the day-to-day operations. It's actually building, not necessarily only consuming software as a service solutions, basically like is the ChatGPT, the free version, but it's more about being able to develop their own Gen AI factory inside the technical architecture solutions, basically, in order to address what we all tend to use, what we are calling use cases. So the use cases sits on top of generative AI. We call it generically factory, which most of the time sits on top of the data. That data that for years, for many, many years, we are talking that is the real gold in the insurance industry, and not only. But this is the moment where actually the data could be used and could improve the interactions, the efficiency, and the way we are doing business. And we don't want necessarily to jump into the technical stack per se here, but here in this in this slide particularly, you will have just a few of the current solutions that are used in building solutions on generative AI. I don't know, Mark, if you want to do some mentions in here or to make
so if you look at the bottom on the far left, data platform, all AI requires data, and we need to be able to process data in a variety of different ways, whether it's unstructured data like emails, or structured data from databases. It could be real time coming in, it could be in batch. That's all got to be quality, go through a quality pipeline. And these tools that you see on the bottom left are vendors that we use to help clients manage that quality. And if you don't get, it's basically, you've heard of garbage in and garbage out. If you don't get the input right, you're never going to get the output you require. So that's the key. The data platform is a key part of the whole thing. Then the data comes out of that essentially and goes into what we're calling ML, and well, actually it's now been called LLM ops. So it's an operations or development to operations pipeline. So the data comes into the developers, creating the models where you can see there Azure, machine learning, etc. Those are tools that we use to create the models, the machine learning models, and then it goes out of there into an operations environment. So and you've got the models on the far right under the LLMs. So you've probably seen some of these symbols, like the top left one is from OpenAI, but there's Mistral, the big M there, there's that. You can see the Meta symbol there. The Meta's got Llama, and there's various models. They're all sort of like a Cambrian explosion of models that's happening at the moment. People are bringing out big models and small models to run on devices. So anyway, that's a bottom level, but it's only to enable the level above. So all of these topics have been there forever, haven't they? Security, access control, configuration, how do you configure the system to perform the way you want it to do, how do you integrate it with other systems and release it and observe what's going on. So we've got that whole layer still in existence, but obviously it needs to cope with predictions coming out of the bottom layer. And putting guardrails in place with one key thing you'll hear Daniel and I talk about when it comes to Gen AI is the word hallucination. I won't steal Daniel's thunder on that because he's got a slide on that, but LLMs always hallucinate. It's fundamental nature of LLMs. And we need to put all those guardrails and security in, because it's a regulated industry that we're working in. We have to put all of that around the LLM to be able to get the output that we require.
An obvious question that comes into my mind is the following. Is this complexity really necessary? Because at least as a consumer, it seems generally it's pretty simple. I just install an application and I'm just writing prompts and I'm seeing the results. But if we are moving in the enterprise level, is this complexity really needed?
It's a really good question.
Can we just plug and play and use it? Because shouldn't this make our life easier? Yeah. And if we go to the easiest route, then what some caveats some risk might be in there. So I don't know. If you have a short answer, I don't know. I know it's a very complex topic.
Took a very, very simple case. You go to ChatGPT, as most of us on the call have been, and you type something in, or now you can upload documents into it. Where do you think that information is going? It's going over to San Francisco where it's hosted. Where's it going there? Who's protecting the information? What about GDPR? How do you get rid of your information from their databases, etc., where it's all going? So it's fine for casual use, let's call it, where you're not disclosing any personal information, but people don't really know that. And they can get into issues, especially if you're dealing with corporate information, where it goes all into that. And then what happens with ChatGPT, because it's all essentially going to a central place, if Daniel was to then type in a query into the prompt into ChatGPT, he might see my commercially sensitive or even personal information pop up. That's a real scaremongering type attitude, but that's essentially what's happening. So what we need that layer for, in the middle layer on that diagram, is to protect the organization from all of that going outside of the building, so to speak, and go into the people's hands where they shouldn't have it, to protect personal information, our PII and GDPR speak, and commercial information, right? So that's one example.
So definitely we could say, please don't upload ever proprietary information or PIA or any other topic inside a public GPT model, because you risk to put your organization at risk, definitely. So thank you very much, Mark, for that. Okay, so now navigating through the complexities, let's see the use and what are some use cases or some areas where basically generative AI could have applications in insurance. And I'm pretty sure, and we've seen in the last months, a lot of, let's say, meetings, webinars, summits around Gen AI, and there is a lot of fuss about this. And it really makes sense because generative AI right now, it is on the hype. We have in this slide, we have just pinpointed some areas where basically we do feel that we will see more and more applications on generative AI and generative AI factories, like we were mentioning before. But instead of reading this slide, I will share from our experience and from the last 5 to 6 months. We had talks with various organizations, with various customers in various territories, starting from the UK, in the US, Asia Pacific, Europe, basically. And I would say with most of our customers, and not only in the industry, the discussions goes mainly into directions. One of it, which is, we could say, the obvious one, it's more about how we could bring efficiency in the, let's say, front side operations, customer side operations, broker operations, by using some of the organization, they already use chatbots. But the question is how we could make these chatbots even more smarter. Can we enable them with generative AI and having large language models behind that and provide that feeling that we are having currently with ChatGPT? This is one area of discussions, how we could make our chatbot smarter and do more and more operations. And the second topic, it's more about how we could basically parse and understand vast amounts of data and documents and making summaries out of that. And definitely making and taking summaries out of, I don't know, tens of hundred of pages, or basically getting some data from unstructured data and understanding in a claims process, images and text. Or in the digital coat and bind, basically, if the customer is uploading let's say the TNC with the current insurer, and basically we do want to provide a better coverage, could this sort of model make a summary and earn us time in order to be able to provide advice, better advice and better coverage? So these are the two areas basically where organizations are seeing impact, and some of the use cases that are analyzed currently. And we will tell you in the slides after this what is our take on that and what we are suggesting. But before that, let's see if up to date there are any case studies in the real world, and if we have some models in the insurance industry that it's there in an operational environment and not only at a proof of concept level. We have seen probably more than tens of millions invested in various implementations around the world. But up to date, we have just extracted 3 insurance players basically in various territories that have announced basically that they have launched their initiatives on the generative AI. One is Munich Re, and it's quite fresh. It's less than a month when they were announcing the fact that they have launched an AI assistant, basically, that will enable and let's say this solution will enable a Copilot experience in the sales process. Then Miller, the insurance broker that it's headquartered in London, also they have launched, actually I think they were one of the first that have announced last year December that they have launched an internal tool which was based on the OpenAI protocols and Microsoft technologies. Last but not least, ClearCover in Canada, basically they have just launched 6 weeks ago a tool that it's made mainly for ingesting the data and providing summaries in the first notice of loss in the claims process, hence trying to improve the customer experience overall and decrease the time needed in order to settle a claim. So these are, it seems that right now we don't talk anymore about proof of concept. So we do have various MVPs in various regions. I'm pretty sure that in the following months or year, basically more and more, we will see more and more news in this regard. But before jumping into how we could use this, I guess it's critical for us to understand ethical considerations and especially the challenges that generative AI might pose to the entire environment. Mark, do you have any points on this that you would like to specifically outline?
We did talk about the middle one, about data privacy, only just about, if you're using public available chat GPTs, your information is going to go, and you need to make this assumption it's going to go into public domain. essentially. So the data privacy, when it comes into the organization, when you start using LLMs inside the organization, you need to be able to have this essentially an application in front of ChatGPT. If you imagine that the way you talk to the large language model is through an application that starts to put in place got what we call guardrails around what can go into the LLM and what can come out of the LLM and go and what. So, for instance, you don't, when you start using inside an organization and querying the LLM for information, you need to be have the same sort of controls as any other system. So role-based access control is what we normally use in this thing. So are you allowed to see this information? Something needs to enforce it over the top of the LLM. The LLM will just give you whatever it sees, right? So data privacy, especially in we've got complying with data protection regulations, so GDPR and PII, we just mentioned that one. The top one, bias. Interestingly, AI bias has always been there. Whenever you train an AI on a corpus of data, you're essentially giving it a bias. You're saying, here's a picture of a cat. You're biasing towards what you actually want to see. The problem about that is you've got bias. So if you want something else and more flexibility, be biased to whatever you've been training it on. So there needs to be, as it says here, diverse training data. So instead of just having very narrow pieces of information that you're feeding it, give it a diverse set and give it a regular order to check on the output. Make sure you've always got the human in the loop. I think there's a long way to go, I think, with AI, never mind Gen AI, where we can actually say the human is out of the loop. There's a lot of scaremongering about people losing jobs and things like that, but it's mainly at the stage at the moment. We'll get on to futures in a bit, but mainly at the stage, at the experimental stage. Daniel mentioned hype. There's been a lot of hype. I think it's probably going down the other side of the hype cycle now, where people are going, oh, how do we get this into production to get into real use, to get real value from it, rather than write a shiny toy that you can get some interesting answers out of it. Well, these three things come into that other part of the hype cycle where people are going, we can't quite use it in this way. We need to put these controls around it.
On the other hand, talking about bias and fairness, especially in the insurance sector and in the, I guess one example is that with these models, we could actually enable even better compliance with TCF, treating customer fairly, when and if we pay enough attention in not building any biases in the pricing model and being able in the same time to price similar risks at similar codes, which probably it's a bit more difficult with the, let's say, current systems. But with the generative AI tools, if we are paying attention and we are mitigating the risk of not building biases into that, could help us in being able to provide fair codes for similar risks. Last but not least, I've put as a separate topic hallucinations and a real life example on that, because we have heard a lot about hallucination in general, but it really has an effect on the real life. And I've put here an extract from Air Canada, which basically is the first case in US where basically they have losses. They've made a loss in court based on the chatbot that hallucinated a fake customer refund. So although the customer was not qualified to get a refund for a specific ticket, given the fact that he was asking that to a chatbot and the chatbot hallucinated in that area, basically the chatbot fabricated a policy that didn't exist. And of course, the company was liable for that. They were trying initially to mention that the chatbot itself was liable, but the chatbot was actually a propriety of the company. So therefore, the company, it is liable. Definitely, there are a lot of minimizing the hallucination. It's an ongoing challenge in general in the AI development. And some of the techniques might include what I was mentioning even in the short lexicon, using retrieval augmented generation. So combining LLMs with retrieval mechanisms to ground responses in verified data. Then fact-checking algorithms that could help also implementing systems that cross-check generated content against the trusted sources. And last but not least, what Mark was mentioning in that, have the human in the loop. And that's why even us, we are suggesting to have or use Gen AI as a copilot, not the pilot. So we are driving things. Of course, generative AI could help us in our journey, but the decision sits with a human fellow. Good. Now, as a showcase, we have chosen, instead of showing you a shiny front end that I'm pretty sure you have seen across the various presentations, we have chosen rather to explain you what happens really under the hood of such a system. So we do have various, let's say, front ends like a mobile app or the typical web form where you might see a chatbot, the typical chatbot, and we could tell you that yeah, it's a smarter one because it is fueled by an LLM. But in the following slides, Mark will guide you through and will explain you what's happening really under the hood, just to understand a bit better the complexity behind that simple interaction with either the customer, the adjuster, the underwriter, or who else is using the system. So Mark, to you.
So simply trying to understand, because a lot of Copilot's another buzzword, right? So what do you mean by a Copilot? And our interpretation is fourfold here, as you can see. We've looked at the, because generally with technology applied to insurance end-to-end process is across this quote to bind and claims journey, as we all understand. But there's two aspects of what we see as a Copilot: externally facing from the business out to your end customers. We're calling that insurance customer. And underneath that, I've got automated and RLHF, reinforcement learning, human feedback, which is essentially what we're saying. The human's in the loop saying yes or no to the actual end result. But we're looking at automation there, which is we'll come back to. But internally within the organization, we're saying the insurance provider, the employee, needs to have help, right? They can do their job very effectively, but they need to do more with less, as we all need to as employees, more efficiently, but also effectively. So this is an augmented solution as a Copilot. And the way that, say, where this Copilot word seems to come from Microsoft, it's more fitting in that bottom layer of helping people do the jobs a lot better with the tools that are currently available. So, for instance, finding information wherever it is and bringing it, as Daniel said, into summarization, for instance, would be a really good use case. Just to summarize claims, find me a claim that's similar to this, right? That's actually quite a hard thing to do, especially when you've got to integrate with a wide range of sources. Where this Daniel's flipped onto the ethanol process evolution, right? So we've chosen here just one of the four things that you saw before, which is to do with the external. So we're talking about automation. We're looking at how does an ethanol progress from where it currently is in a lot of cases. Email comes in from a broker into an insurer, and that contains the claim. Well, there are traditional AI techniques called natural language processing or natural language understanding. You basically feed it the NLP, strip out the actual real entities and intents that's in that email, and then you put that into a structured system, your normal operational database. Well, if you go back a bit, please, Daniel, just want to go down to the next stage would be of evolution. And a lot of people have done this in ethanol, is they've created a forms-based interface where a client can put in a claim without it sending an email. The Microsoft Copilot area is more to do with, as we said, more augmentation, where it is actually allowing you to bring the LLM, the reasoning engine, into those forms. So you can actually, if you've still got forms you've got to go through, but you can start typing things in and it starts to understand what you're saying. So it's a bit more intelligent than just standard forms. Conversational AI, where it's actually a pure LLM guided chat, where the flow of the whole process through FNOL is reasoned by an LLM. It's not generated by the human being. That's the intent about the conversational AI. So it enables you to have a much more personal interaction, personalized interaction. You log in again, you put the same information in, you get a completely different response. And also you've got sentiment that it can look at, whether you know, how you're feeling as you're doing it, and tuning itself to you. That's a big leap from the intelligent forms. And then finally, where it's all going is where the LLM can actually be the brain that drives interaction with other systems. So you could say, start putting the claim in, and it's cross-checking. Say if you put property details, it's already cross-checked against the existing property database and confirmed, you know, your property is valid. There's no fraud. You know, it's about fraud management as well that's going on in the background there. So an agent is where we're almost, I'd say by the end of this year, there's going to be a Microsoft a tool available to allow you to start creating those agents. So sorry, Daniel, next one.
Going in the same area, like how we could make our current chatbots more smarter and better, we have this slide basically on the conversational AI design. So Mark?
Yeah. So here we go. With the traditional chatbot, we've all used them on websites, and they're pretty clunky, but basically they're robotic. Somebody's gone and created the flow of all the Q&As, the questions and answers, and it feels very much like, you know, if you ask a question that's outside of that, and I've done it a number of times, I've asked a question and you can't answer it, it's quite frustrating, because the only resort is to say, do you want to speak to a human agent, right? What we're trying to achieve in the industry to move towards conversational AI, where you're being more flexible, let's say, on how you have that conversation. So you actually feel like you're chatting to a real human being. And so if in the claims, if the FNOL example, you're trying to put a claim in, it's asking you questions. You're giving it the answers, but halfway down, you might think, well, actually, I want to see what I'm covered for. Ask a question. So you can ask a question and it can cope with a switch in the conversation, just like human beings. So it doesn't have to be a robotic, pre-planned flow. It's a very adaptable flow. But we'll go into the depth of what that is in a second. Right, so this is where we're currently looking at, is the current state being, as we said before, forms on the left-hand side. Use those for, if you're lucky. I mean, some people haven't even moved to a forms-based FNOL. And then underpinning that is a lot of hard work that developers have done with the business to define all that we talked about the Q&A flows, the decision tree. That's all in that logic layer. It's hard coded, it's very brittle, hard to change, and the result is the experience to the end user is robotic. It uses a data layer. What we mean by a data layer is all the pieces of information that you need to capture from the end user to place the claim. We're modeling what that should look like and the relationship between those pieces in what we call a data layer. That stays the same as you move from left to right. But what's different is in the UI layer, instead of forms, we now have conversation. Instead of the fixed logic layer, the decision tree already pre-planned, we have the LLM. The LLM is reasoning across the pieces of information that you told it in the data layer. You said, go and get this information for the end user. And that's a complex ask, right? But it understands how to navigate across that data layer. No matter how the end user wants to interact, it can cope with that as long as it ends up with that data. And then the human in the loop, we called it reinforcement learning, human in the loop. At the end of the whole flow, we make sure we've captured it correctly. That's the key thing, by the human being, which in this case is the end customer placing the claim, saying, this is what we've captured from you. So you've had that great experience, personal experience coming all the way through. You've been able to switch to ask questions whenever you wanted to. And then you eventually ended up with, this is the information that we're going to submit. So you still end up with the same information in the end of the day that you get on the current state with the future state, but the pathway through is far more personal. And of course, it's adaptable as well.
And faster, and we bring more efficiency in the process, basically. So,
and also the development effort. In order to create the left-hand side, it takes an inordinate amount of effort for everyone to think about all the different flows through a Q&A that could possibly happen, because they're dependent. These questions are dependent on each other. Whatever you say back is asking you another question, right? To actually map out all of that and test it. And then if you have any more changes, which you naturally will do in running a business, you want to change the products, you've got to then go through the whole life cycle again. On the right-hand side, what we're saying is the top two layers, we're trying to get it into a situation that it intelligently reasons across the data layer. So the data layer, if that changes, then obviously it would need to interact and need to test it. But the development cycle, we believe, to Daniel's point, is going to be vastly reduced and therefore cost saving. So you can't, apologies for this slide. I was trying to get some interesting things to show you there all in one go, but I think I failed because you could hardly read it. So I'll read it for you. Essentially what you've got here is remember one of the 4 copilots. This is where you've done your FNOL and you're now into claims adjuster view. So inside view, employee claims adjuster sitting down and chatting with this is a concept system. And essentially what that person's doing is asking for more information. So you can't read it, but I'll read it for you. So the top one, it's saying, please give me claims related to this particular claim that I have I'm working at the moment, similar claims. Now the similarity, and we'll get on to that, is actually quite a complex process, which Daniel was talking about, which involves RAG, retrieval augmented generation. And also you've got to turn all the information that you collect, images and text, whatever that it pulls out of RAG. You have to convert all that into what's called vectors and store it in a vector database in order to get the similarity in, because similarity is across a number of different features. It's not just 1 or 2, it's a whole bunch of features that you want to see how similar it is. So this is a dynamic dashboard on the right-hand side, meaning that it starts off blank. And by the chat on the left, you're literally saying, show me this, show me that, right, as you go. So one of the next questions are, please show me a relevant police report, on this particular claim. And then the final one with the arrow going to the bottom right is potential settlement amount. What I put there is a bell curve distribution, where basically you're deciding which claims you want to auto settle, which is the left-hand bar. And obviously you want that to be as big as possible, but as reliable as possible, because that's going to save you money in processing them. And there's a vertical bar on the right-hand side of that bell curve distribution, which you then need to escalate. It might involve some fraud or something, prediction about where it's actually going to explode in costs. So you might want to escalate that. That bell curve distribution is showing the claims adjuster where this claim sits amongst all the other claims, right? And how it can, the confidence factor of being able to adjust that claim for the right amount to settle. So the whole purpose of this Copilot inside is to do what they're already, it's just tools to enable somebody to do what they're already doing, but far more flexible by talking to a machine that's already collected all this information together, and you can present it in different ways. And the final bit is dynamic. So you can create these graphs dynamically, whereas for so long we've had to develop dashboards which are fixed, right? Here, this is
basically correct me if I'm understanding correctly. What you are saying is that the magic behind this is not necessarily how it looks necessarily specifically this user interface. It's more about the fact that I could require some dashboards that in the traditional way there could be at least one human or more, a team of humans that will need to develop and write code. And in this context, basically the Gen AI, probably some code it is written, but not by a human, basically. And the Gen AI, it's doing that instead, and is generating what I need on the go, on the fly. Basically.
On demand, absolutely. And flexibility, the same paradigm as the FNOL, where it's flexible, adaptable. It understands where you are in the whole process. It can pick up wherever it left off and show you, as you said, things dynamically as you go, not static world anymore.
I can hardly wait to meet such a smart assistant that will make our day-to-day life easier. So going forward.
So this is, sorry about, again, the complexity of this, but basically just look at it as two bits. The end user is talking to an app. In this case, it's a Python. It's a code that's written in. So notice that it's talking to the app. It's not talking directly to LLM. Remember the thing that Daniel and I mentioned right at the start about ChatGPT. We need to put guardrails around that LLM. And the only way we can do that is put an intermediate application in between the two things. So that's why the application is there. You're talking to this app. The app's then talking to what we call tools, which is essentially tools for the LLM. The LLM is only the brain. It's not that they haven't got any arms and legs to do anything. They can only come back with answers. They can't do anything on their own, right? The way where they can do it is through what we call tools. So we tell the LLM, we say, here's a bunch of things that you can do. You can go and check this property details, right? You need to call this API to call some database, right? This is how you do it. So give it a whole list of things you can do. And then you allow the LLM to reason across the conversation you're having to say, are you allowed to access this information? If so, yes, you want me to do this? Okay, I know how to do that. I'll go off and get this information and come back to you. So it's a whole sequence, and when it's a whole session on itself, just go through all of this. But it does show you that there's four main vertical bars or components involved in this.
So looking at this, it seems that large language models will still require, or the machine learning algorithms and services are still required there. So basically, generative AI is not replacing the, let's say, older initiatives where we are trying to build some machine learning algorithms that will help us, I know, especially in the fraud prevention or on the claims triaging or doing different other use cases where we are using machine learning as a tool. So it can still be of use.
Yeah, and so exactly, Daniel. So where you see the ML service and the tools, that's essentially the way the LLM as the brain is able to go and use its arms and reach out to wherever you currently got the information stored, or you might have existing ML models or algorithms. You can still use all of that through the tools interface. So you're augmenting wherever you've got, not rip and replace, you're building on top of it.
Excellent. And the last part, which is we try to simplify it as much as possible, but I guess it's that will give you enough information, still in not a very detailed manner, in order just to navigate and engage better with various people in your organizations or with the IT organization, but not only. So if you'd like to explain us a bit, I mean, 2 minutes, basically, Mark.
Yeah, very, very quickly. This is trying to bring you together what Daniel and I have been talking all the way along, the key buzzwords that we mentioned right at the start. So front end, you're the end user, you're querying the UI. You essentially, when I say query, you're giving it a question, and then it goes off. Where does it go off to? It goes off to something called an embedded model. Well, this is the point that I mentioned earlier about it can't look for similarity by just text. We need to convert everything that is required to be like similarity into numbers. The numbers essentially get produced by the embedded model and stored in a vector database. The numbers is essentially a vector, right? So essentially what it's doing, whatever you've typed in, it goes off to the vector database and then pulls out information relevant to the query that you put in. So essentially imagine this is where RAG is behind the scenes. It's coming back with whatever it's found in your organization into chunks, and it's putting those chunks into the prompt. Essentially it's building this prompt up based on what you've typed in. And also it's including your original, if you notice there from the UI, there's a line going to the embedded model and another line going to the initial prompt. It's putting two pieces of information together into that initial prompt. Whatever it's found out there inside your organization to make the query relevant to your organization. That's the big thing about RAG, is it's not looking outside your organization, it's looking inside to whatever it can find. And the other part going into initial prompt is what your original query is. And what essentially, through optimization, et cetera, it's coming back with an output to you. So the key with all of that is the top right, because what it's doing, it's using retrieval augmented generation, which uses embedding and vectors and various other components to come back to you with relevant information. Not just, well, if you go to ChatGPT, you got whatever it's trained out in the whole wide world, but nothing inside your organization because it can't see inside your organization, right? This enables it to see inside your organization, be relevant.
Excellent. So, being conscious of the time, it seems that what we've tried today basically was just to demystify or simplify and enable you to things about generative AI and enable you to understand important aspects of how you could try to make use generative AI in your own organization, in your underwriting or claims functions. And if you need support on our side, both Mark's and my email addresses, you will have it in the following slides. And basically we'll be more than happy to engage in various discussions and help you and enable you to understand how you could make of the real use out of this. Hopefully you enjoyed the session and hopefully you will touch your learning objectives, like describing the role of generative AI in insurance and how to leverage that, outline how generative AI can be used as a supporter tool for underwriters and claims handlers, but not only, and identify some risks associated with Gen AI, as you've seen, hallucinations, and not only that could pose a risk to your organization and be liable in front of your customers, investors, and not only. So if there are any questions, probably we have time just for one question.
We do have one question that's come in. So we're nearly at time. So I'll just read this quickly. But how close are we to really how close are we really to quantum computing? And if this capability is used alongside AI, how much of a game changer will this be for the future of work as we know it?
That's a great question, and that's a tough one.
That's a great question. Yeah, I'll attempt to answer it because I don't know whether anyone knows the answer to this yet. But if you think about LLMs with the big L as a front, large language model, right? They're getting more and more sophisticated. Not only that, they're having to do with more and more volume of data, not just text, images, videos, whatever. So the computational requirement, we talked about data centers, the electricity of Ireland, it's only going to go up, right? So computation wise, we know with quantum computing, it's going to get a lot faster, right? So being able to do trainings every other day rather than what it's, I don't know whether I mentioned, but ChatGPT and all the other large language models are fixed at the date they were trained. So what you're looking at is looking back in time. What I think this will enable us to do with quantum computing is being able to train every day. Therefore, you're looking at, almost real-time information.
My take on this would be that a real potential bottleneck on this would be not necessarily the technology itself, but our ability to generate enough energy for that.
It's good one.
So thank you very much, everyone. And please feel free to reach us, me, Daniel, or Mark on LinkedIn or directly on our emails. And thank you very much, MGAA, for getting us here for this webinar. I hope you have found this very useful and you will get a few important things out of this webinar.
Yeah.
Thank you very much.
Indeed. Thank you so much, Daniel and Mark, for your presentation today, which I'm sure everyone will agree has been thought-provoking and very interesting. You can reach the presenters at the contact details you can see on screen now, or do feel free to contact me at tim.richards@mgaa.co.uk with any questions or introductions, and I'll be very happy to pass these on. Thanks to everyone for joining us. As always, please don't forget to provide your feedback and look out for forthcoming MGAA events, and I hope you all have a productive afternoon. So thanks for joining us. Thanks again, Daniel and Mark, and have a good afternoon.